Of Leetcode with Swift. Um, Today we'll be looking at Leetcode 53. This is part of the series Array Basic Questions. This is probably the last one, and then move on to the next topic. Uh, Actually, let's check out what the next topic is. This is the study plan I've been following. The next thing we'll be looking at is string. So stay tuned for that. Now let's jump back in and look at maximum subarray. Given an integer array nums, find the contiguous subarray containing at least one number which contains the largest sum and return its sum. Sounds pretty straightforward, right? Yeah, I think so too. A subarray is contiguous part of an array. So there is a difference between subarray and subsequence. I could pull it up, but I'm sure you can do your own research. There is a little bit of a difference. Okay, let's look at the input here. So 2, 1, -3, 4, 1, 2, 1, -5, and 4. Okay, so it's a very mixed bag of negative and positive numbers. So we probably have to find the largest value, which I'm hoping is negative. If not, it would be the most negative subarrays. So that's probably the hardest part of this. So let's see which subarray they're talking about. So this first three is definitely not it. 4, 1, 2, that makes it 5. 6, that's it. That's a subarray. Okay, that's the largest sum. If we have a single element, we just return that element. We can have something like this. Let's see, 9 here, 15 here. This whole thing, yeah, that probably adds up to 23. Okay, let's jump into the scratchpad and see a brute force solution for this, and then we'll think about another approach. Okay, let's consider this array here. So initially, the first approach I want to show you is the brute force approach, basically. So let's assume we have this nums array. You can see there's a lot of negative numbers, there's a lot of positive numbers, some positive numbers, sorry, and there's a quite bit of a mix here. So what is the brute force method of finding a subarray that has maximum sum? Um, so the idea is basically very simple. We initialize a maximum subarray here, and we would loop through all of these elements. Let's say the outside loop has ith index, and for at each loop, we'd consider that as a starting index and initialize a current subarray. Now, once we have this, we can loop over once more, picking that the ith index is the starting point and go up until the end. Let's call that index j. So at every instance of jth index, we would add current subarray with nums of j, right? And then check if this max subarray is maximum compared to current subarray. Maximum subarray, comma, current subarray. Now, this looks simple, and it is, because it is the most brute force method you can find. It's kind of like optimized, because we're not really checking the elements behind 1 if our ith index is here. So it is still brute force, so its time complexity is O of n squared, and space complexity is, since we are not using any extra space, no matter how big the input is, we are always using two variables. That's this max subarray and current subarray. So it would be 0 of 1. The brute force approach, the code I'm about to write won't really work, so it's not really of any value. So, but let's see anyway. So let's declare infinity variable. So that's max subarray equals to int dot min, and then for I in 0 to nums dot count, parsing through the entire array, current var current subarray equals to 0. Then start another loop for j in range. Let's not do Python. So that's I to nums dot count, and then we would just be like current subarray plus equals to nums of j, and then we would get this equals to max of current subarray and max subarray, and at the end we would just return max subarray. Now if we had the computation power, this would work. Oh, I guess we have to do this also, since this is a closed range to count for index. Yeah, this is the entire solution, brute force solution, but this definitely won't run. Oh, it runs the normal cases. That's good. These cases too. But the big one probably fails. Yeah. It's a huge array and that won't work out for us. Okay, that's the solution. Okay, now let's talk about the actual solution. Um, so whenever we see something maximum, minimum, always try considering dynamic programming. I know it's like a touchy subject because it's very difficult to really master, but over time I'm expecting I'd get better at it, and I'm hoping you will too. So dynamic programming, basically it's like this particular algorithm we'd be approaching for is a greedy style algorithm. So basically we would just reject anything that doesn't fit our criteria. So let's not talk too much and let's just jump down and see how we can really see what our criteria is. So right off the bat, we can see that if we like just trying to solve the question on my own, is this an optimal subarray? Not really. It's -2, and I'm pretty sure we can find better ones. Is this an optimal array? So the sum of this would be, say, -1. What about this? This is also not ideal. -1, nah, that doesn't work. So maybe the first three block of elements are not really worth looking at. So my basic criteria right now is if it's positive, we should look at it, and if it's negative, we should try to reject it somehow. So let's jump to this part of the subarray. So 4 is fine. 4 with -1 is 3. This is also fine. It may be an acceptable answer. What about this block? 4 plus -1 plus 2, that's 5. Better, better. If we add this part, that's 1. This whole thing becomes 6. And now if we add this, it's still positive. Notice this was negative, so I was kind of apprehensive. So if we add 5, it's still 1, but that's also fine. And then again, if we add 4, yeah, that's also fine. So what I'm seeing here is a pattern, right? Whenever we have a negative number in whenever the sum becomes negative, the current sum, the running sum becomes negative, we have to reset the value to 0 because 0 is better than negative values. So it would go something like go have like um let's call this current sum now. Oops. Let's call this current sum because that kind of makes more sense. And let's initialize this to 0 to begin with. And at each point, we would just we would go through these numbers, and we don't need the index, I think. So let's call the element E at each point. So we go through E, we check if um, current sum is negative. Um, if it's negative, then we'd set current sum as 0. If not, we just continue on. And now if it's not negative, what we can do is we could possibly add element to current sum. So current sum plus element equals to current sum. And now once we have a new current sum, we can check if that's the max value we've ever seen up until now. And maybe we can have a max sum value initialized to 0. So max sum equals to max of max sum and current sum. I hope that makes sense. It's pretty straightforward if you just don't overcomplicate things with algorithms. So the word algorithm is basically like a scary word because it's there's nothing behind it. It's just a number of steps. It's a intuition building, and they're just labeling them up. So let's look at the time complexity for this. The time complexity for this is so we're not really going multiple times over the array. We only have to make one pass. So it's O of n. And as per space complexity, no matter how long the input is, we're not using any extra space that would like increase in size. So it's O of 1. Okay. I would go over the brute force approach, but I think I want to make these videos shorter, so I'm gonna do a, a single approach or maybe two approaches. We'll see. So this was the if you remember, we had okay. So we needed a couple of variables, right? So we needed var sum that would carry all of the current sums, and we'd have a maximum sum which we would return. So let's go ahead and do that immediately. Return max sum whenever at the end. So we want to parse through all of the nums. So we probably don't need the index, so we don't need to go through the range. So we can do for num in nums. And if we would check if the value of current sum is less than 0. If yes, we would just immediately set the current sum to 0. And if not, and then actually if it's we won't put it in the else statement, because imagine if we found a negative number we set it to 0 and start with that negative number, what's the chance that the next number is not a huge positive number, right? So here we would do cur sum plus equals to num, and then we would set the max value. So max sum equals to max of max sum and cur sum, right? Let's get rid of these white spaces. And yeah, that's it. It's small. It says it's a medium, but it's pretty small. It feels like the question was tough, but it's really not. You just have to spend some time thinking and creating the intuition, and you should reach this stage very soon. Let's give it a spin. Let's see how it performs. Oh, there is an error here. So we said we'd set max sum to 0, but it doesn't. So we'd be parsing through the array irrespective of what. So how about we just set the max sum as the first element, nums of 0. Let's give it a spin. Okay, that works. Okay, that ran. Okay, awesome. That was the solution.